Hi everybody. This video will go over section 1 of chapter 9, and in this section we are going to talk about systems of linear equations. We're going to first present the idea behind linear systems. We are going to present two approaches that one can use to solve rather simple linear equations or linear systems with two equations and two unknowns. We will then talk about linear systems with three unknowns and a couple of applications. Okay, so we all know what a linear equation is. Here it is. This is a linear equation in standard form. Now, if you actually happen to have more than one equation, then you have a system. This is a linear system with two equations and two unknowns. And this is a linear system with three equations and three unknowns. Now, for the case where you have a linear system and two variables, you have three possibilities. The first one is the case where you actually have where each equation plots two lines, neither of which are parallel. If that's the case, then there will be an intersection that will occur at one point. That intersection will be the solution of the two equations. Since the solution does exist, we will say that that system of equations is consistent. And furthermore, we will say that these equations are linearly independent. What about the case where you actually have two parallel lines? Well, in this particular case, the lines will never intersect, therefore there is no solution. We say that the system is inconsistent, however, the lines are still linearly independent. And finally, if the graph of the two equations produces the exact same line, we actually have equivalent equations. They will have the exact same solution set. As you can see, it will be all the points on the line. And we will say that the system is consistent because, once again, it has a solution. However, these equations are linearly dependent. Now, when it comes to solving a system of linear equations, we actually have two approaches. The first one is the substitution method. And what you do here is you find one equation, you use one equation to find one variable in terms of the other one. In this case, y in terms of x. Then we will use that equation to solve for y. Once we figure out what y is, we can use that information to figure out x. Now, in the elimination method, what we're going to do is we are going to create an equivalent solution by doing transformations on the equation to eliminate a certain variable, say x. Once we've done that, we will use that equation to solve for y. Once we have found the information for y, we will then go back to one of the original informations armed with our information regarding to y to figure out what x is. And of course, all this makes more sense if we actually do an example. So here is our example using the substitution method. And here we want to solve this particular system. So the first approach is going to be the first thing that we want to do is solve one variable in terms of the other variable, and it would make sense to try to solve x in terms of y. So let's go ahead and do that using this equation right here. And if we do, we will have that x is equal to 2 times y plus 1. Once we've done that, we can take this value and substitute it in for x here. And then we will have 4, instead of x, 2 times y plus 1, minus 3y is equal to 14. Okay, well, using the distributive property here, we will have 8y plus 4 minus 3y is equal to 14. And we can simplify this. We can simplify this some more. 5y minus plus 4 is equal to 14. And then we will have that 5y is equal to 10. We can divide both sides by 5, and we will have that y is equal to 2. So now that we know what y is, we can figure out what x is. And we can take this value and substitute it back into this particular equation right here. And if we do, we will have that x is equal to 2 times, 2 for y, plus 1, which gives us 5. And so our solution will be the ordered pair 5, 2. Okay, well, how does the the elimination method work? Well, once again, what we want to do is we want to transform these equations so that we come up with an equivalent equation with only one of these two variables. So what we can do is we can multiply this equation by 2 and this equation by 3. This would be one transformation. And if we did, we would have 4x plus 6y is equal to minus 2. And then we will have 9x minus 6y is equal to 54. Now the next transformation that we can do is the addition of these two equations. And if we do, this will cancel. We will have 13x is equal to 54. Dividing both sides by 13, we will find, I'm sorry, not 54, this should be negative 2 minus negative 2 plus 54, which will be 52. And then we will have that x is equal to 4 when we divide both sides by 13. Now that we know what x is, we can figure out what y is. And which equation do you want to use? Doesn't particularly matter. Any equation will be fine. Let's go ahead and use the second one. We will have 3 times x, which will be 3 times 4, or 12, minus 2y is equal to 18. Well, that implies that minus 2y is going to be equal to 6. And that y is equal to minus 3. So our solution will be the point 4 minus 3. Now does that work? Well, let's go ahead and find out. 4 times 2 is 8, plus 3 times minus 3, that's negative 9, and 8 minus 9 is indeed minus 1, so it does indeed check out. Now remember, there are two special types. There are two other cases that we need to concern ourselves with, and this is an example for case 2. Here we have an inconsistent system. And what will happen if we try to solve a system with, well, no solution? Let's go ahead and find out. Now what I can do is I can multiply the first equation by 4. And if I do, I will have 14x. Actually, not by 4, by 2. What was I thinking? 14x plus 6y is equal to minus 10. And then when I add vertically here, I will have that 0 is equal to minus 20. This is a false statement. Also known as a contradiction. As a consequence, if all this results in a false statement, that means that there is no solution. And the solution set is the empty set. Okay, what about the case where the system has infinite many solutions, where both equations is the same line? Well, there's lots of ways that you can actually show that. For example, if you multiply the bottom equation by negative 3, you're going to get the top equation. If you solve both equations for y, you would get the exact same equation. But however, using the let's see what we get if we try to use the elimination approach. Okay, so what we're going to try to do is we're going to try to eliminate the x's. So what I'm going to do is multiply the second equation by 3. And if I do, I will have, well, let me rewrite the top equation. Negative 9x plus 3y is equal to 24. And then for the bottom equation, I'm going to have 9x minus 3y is equal to 24. This should be negative 24. And when I add, this cancels, this cancels, this cancels, I have that 0 is equal to 0, which is a true statement. So the solution to this system of linear equations is going to be all the lines or all the points on the equation y is equal to 3x minus 8. And of course, we're going to have some examples that we need to deal with. Now here we have a range. In this particular range, we have, it turns out that 6 goats and 5 sheep sell for $305, while 2 goats and 9 sheep sell for $285. And we want to figure out the cost of a single goat and the cost of a single sheep. Okay, so let's let X be the cost of a goat. And let's let Y be the cost of a single sheep. If that's the case, then 6x plus 5y is equal to 305. 2x plus 9y is equal to 285. And we're going to use the elimination method, so what we can possibly do is multiply the second equation by -3. If we do, we will have, once again, for the first equation, 6x plus 5y is equal to 305. But for the next equation, we are going to have -6x minus 27y is equal to -855. -855. Adding these together, we have that the 6's cancel. We will have -22y is equal to -550. Dividing both sides by y, we will have that y is equal to 25. Now with that, we can use that information into either of our 2 original equations to figure out what x is. Let's do the first one. In that case, we are going to have 6 times x plus 5 times 25, which is 125, is equal to 305. That is going to give us that 6x is equal to 180, or that x is equal to $30. Okay, so we have that the cost for a goat is going to be 30 bucks, and the cost for a sheep is going to be equal to 25 bucks. And that brings us to solving linear equations with 3 unknowns. And how do we do that? Well, basically, we do it the exact same way that we do equations with 2 unknowns, except now we actually have to eliminate 2 variables to find the third instead of just 1. So we are going to take 2 equations and use those and transform those 2 so that we eliminate a variable. We are going to then take a different pair of 2 equations and eliminate the exact same variables. So then we will have 2 equations with 2 unknowns, and we can actually find one and both of those variables with those 2 equations and 2 unknowns. Once we have that information, we can find the third variable using one of the original 3 equations. So what does this look like in terms of an example? Well, here we go. Here's our example. Now the first thing that we're going to want to do is try to eliminate z, because that appears to be the easiest. So I'm going to use this equation and this equation to eliminate z. And that will give me 3x plus 4y minus 2z is equal to 14. 2x plus y plus 2z is equal to -9. Let me put my lines through z so you actually know they're z's. And when we add these together, these will cancel. We have 5x plus 5y is equal to 5. Okay, next I'm going to combine these 2 equations. I'm going to do that by multiplying this equation by 2. And if I do, I will once again have 3x plus 4y minus 2z is equal to 14. And then I will have 2x minus 2y plus 2z is equal to -18. Okay, adding these together, these cancel. I have 5x plus 2y is equal to -4. Okay, Now notice how I have a 5x here and a 5x there. So what I can do is multiply one of them by -1, and then I can eliminate an x. So I'm going to multiply this by -1, and that will give me that I will start up and I will have 5x plus 5y is equal to 5 here, and then I'm going to add -5x minus 2y is equal to +4. And adding that together, the 5x's cancel. I have 3y is equal to 9. Y must be equal to 3. Okay, with that in mind, I can now use either of these two equations to find out what x is. And let's go ahead and use the second equation. And here I will have 5x plus 2 times y, or 2 times 3, which is 6, is equal to -4. Okay, well that implies that 5x is going to be equal to -10, or that x is equal to -2. And now I can figure out what z is. And probably the easiest equation to use would be this one, since it has so few coefficients. And then, since I have -2 for x, I will start off with -2 minus 3 plus z is equal to -9. So -5 plus z is equal to -9. Z must be equal to -4. And therefore our ordered 3 tuple is going to be -2, 3, -4. Now, one of the things you'll be asked to do is to solve a linear system in terms of z. So here we actually have what we call an underdetermined linear system. 2 equations, but 3 unknowns. However, we can solve each of these. We can solve each of these equations, two of these variables, in terms of a third, and that's what we're going to do. And we're going to do this with we're going to try to solve x and y in terms of z. Now, to do that, we need to eliminate not x, but perhaps one of the other, not z, but one of the other 2 variables, such as maybe y. And we can do that by multiplying this equation by -2. And if we do, I will have -6x minus 2y plus 4z is equal to 14. And now I can add these 2 equations together. I will get -x. These will cancel. Plus 5z is equal to -6 plus 14, or 8. And then that will give me that x is equal to 5z minus 8. Once I have that, I can then figure out what y is, and I can use any equation I want, but let's go ahead and use the first equation. So here I will have 3 times x, which is 5z minus 8, plus y minus 2z is equal to -7. Okay, I can distribute here. That will give me 15z minus 24 plus y minus 2z is equal to -7. Notice I have like terms 15 and -2, so that's going to give me 13z minus 24 plus y is equal to -7. Okay, now I can move these 2 terms over to the other side, and that will give me that y is equal to -7 plus 24 minus 13z. And that will give me my final result, which is that y is equal to 17 minus 13z. And these are our equations for x and y. Now the next 2 problems are actually applications. And in this particular one, we are going to start off with the equation of a circle. 3 points that are on the circle, and we want to find the value of the parameters of this equations, which would be a, b, and c. You are also going to find problems where you actually have to do this for a linear equation, ax plus b. Actually, I think it's y is equal to mx plus b, and also for quadratic equations where we have ax squared plus bx plus c. Now, when you're solving for the linear equation, you are basically solving for two parameters. So this you will have 2 points, and you will have a two variable and two unknown situation. For a quadratic equation or for a circle, you have 3 unknowns, so you'll need 3 equations, and you'll be given 3 points, just kind of like what we have here. So here we have these 3 points, and they are going to fit a circle. And we need to figure out the parameters of this circle, namely a, b, and c. And what we're going to do is we're going to substitute x and y for these 2 points and see what we get. So let's go ahead and do that for 2, 1. That will give us, well, x squared is 4, plus 1, that's y squared, plus 2 times a, plus b, plus c equals 0. Okay, for the next one, which is -1, 0, we will have x squared, which is going to be 1, plus y squared, which is 0. That's plus ax, which is going to be -x, plus by, which is just simply 0, plus c is equal to 0. And then finally for 3, 3, we will have 9 plus 9 plus 3a plus 3b plus c equals 0. Okay, we can manipulate these equations a little bit, and we will have that 2a plus b plus c is equal to -5. Over here we will have -a plus c is equal to -1. And over here we will have that 3a plus 3b plus c is equal to -18. And these are the 3 equations that we want to solve. So the first thing that we can possibly do are combine these 2 equations right here. Let's do that on this little side right here. So we are going to have, first we're going to multiply this equation by -1, and then we will have 2a plus b plus c is equal to -5, and then on the next side we will have a minus c is equal to 1. And this should be a -5. When I add these up, the c's cancel, and I will have that 3a plus b is equal to -4. Okay, now for the next one, I guess I'm going to want to do these 2 right here. Okay, and I will do it the exact same way. I will have that 3a plus 3b plus c is equal to 18, and then multiplying the middle equation by -1, I will have a minus c is equal to 1. And I forgot the -18 again. Let me put that down there. There we go. Okay, when I add these together, I will have these will cancel. I will have 4a plus 3b is equal to -17. Okay, now what I want to do is I want to combine these 2 equations, this equation and this equation, but I want to multiply this equation by -3. And that will give me -9a minus 3b is equal to 12. And over here I will have 4a plus 3b is equal to 17. Okay, adding these together, these cancel. I have -5a this should be negative 17. Negative 5a is equal to negative 5. Negative 5a is equal to negative 5. And that would imply that a is equal to 1. Okay, so I have that a is equal to 1. Once I have that, I can use this equation or this equation to figure out what b is. And I'm going to go ahead and use this one. And over here, I have that 4 times a, or 4 times 1, which is 4, plus 3b is equal to negative 17. Okay, well I can subtract 4 from both sides, and that will give me that 3b is equal to negative 21, or that b is equal to negative 7. So that is my value for b. I have a is equal to 1, and b is equal to negative 7. Now all I need to do is figure out what c is, and I can do that from any equation that I want. Perhaps I can use the middle equation. In the middle equation we have that negative a, which is negative 1, plus c is equal to negative 1. Well, that implies that c is equal to 0. So here we will have that c is equal to 0. Okay, and this is my last problem. Now this one's a little involved, so I'm going to go ahead and do this over here in OneNote. And notice what we have. We have an investment of $63,000. It's going to be made by some business club. This investment is going to be split into 3 parts, where one part, I'm going to call that X, is going to earn 8% interest. The second part, I'm going to call that Y, is going to earn 6% interest. And then the last part, Z, is going to earn 9% interest. Okay, well, if the first part, which we're going to call the amount X, earns 8% interest, then the interest from the first part is going to be equal to not 8%, but the decimal version of that, which will be 0.08 times X. The second part is going to be equal to 0.06 times Y, and then the interest from the third part, which of course is going to be the amount Z, is going to be equal to 0.09 Z. Now all 3 interests, all the interest from each of the counts, I1 plus I2 plus I3, is going to add up to $5,130. Or more importantly, 0.08x plus 0.06y plus 0.09z is going to be equal to $5,130. So we have 2 equations. The first equation is that all 3 parts is going to add up to $63,000. So x plus y plus z is going to be equal to $63,000. The second part is that all the interest is going to sum to $5,130. So 0.08x plus 0.06y plus 0.09z equals $5,180. No, $5,130. And this right here provides us with our last equation. The interest from the first investment was 5 times the interest from the second, which means that I1 is going to be equal to 5 times I2, or that 0.08x is going to be equal to 5 times 0.06y, or that 0.08x minus 0.3y is equal to 0. And that is our final equation. Now it is going to be somewhat difficult to work with these decimals, but we can convert these decimals to integers by multiplying this equation by 100 and then this equation by 100. And then our three equations will be x plus y plus z is equal to 63,000. And then our next equation will become 8x plus 6y plus 9z is equal to 513,000. And then finally over here we will have that 8x minus 30y is equal to 0. Okay, so what we probably want to do is to combine these two equations to eliminate z. And what we can do is we can multiply the top equation by -9. Okay, and that will give me that 9x, -9x, minus 9y, minus 9z is equal to 567,000. And I want to add to that 8x plus 6y plus 9z, which is equal to 513,000. Okay, adding those two equations vertically, we have that the z's cancel out. And then I will have negative x minus 3y is equal to negative 54,000. Okay, so now notice that I have one equation in terms of x and y and another equation in terms of x and y. So now all I need to do is maybe I can eliminate x by multiplying this equation by 8. And if I do, let's go ahead and do that. I'm going to multiply this by 8. And that will give me negative 8x minus 24y is equal to negative 432,000. And then I'm going to add this to that, this equation to that. That will be 8x minus 30y is equal to 0. Of course, the x's cancel. And over here I have 54y minus 54y is equal to negative 432,000. And if I divide both sides by negative 54, I will find that y is equal to $8,000. Now we can go ahead and figure out what x is. And of course we can use this equation to figure out what x is. And there we will have that 8x minus 30 times y, which is going to be 240,000, is equal to 0. And that means that x is going to be equal to $30,000. Okay, so we have that x is equal to $30,000. That's the amount for the first investment. We have y is equal to $8,000. And now we can figure out what c is. So we can go back to the first equation. The first equation is x plus y plus z is equal to $63,000. So we can go ahead and use that, and that will imply that z is equal to 63,000 minus x, which is 30,000, minus y, which is 8,000, and that will give us $25,000. So z is $25,000. And those are the way that this investment will be split. And that is all I have for this particular video. If you have any questions, please feel free to contact me. This is Bob Boyle, signing off.